here to welcome you and be the MC to get us started. Like I said, make sure you have your popcorn and your soda. There's plenty more of that. We have a number of wonderful volunteers here, and I do want to stress that this event is 100% volunteer run, led, generated, and so give them all a big round of applause. You will see some volunteers in a blue lanyard, some with an orange, I think it's orange or red lanyard. For those, please listen to the volunteers. If they ask you to do something, please just comply. Appreciate that. Also, please don't touch the creators. I know they're celebrities and you want to get close to them. No touching. And also, just sort of take your turn. I know it's fun to come try to rush the stage, but afterwards, please give them a little space and the volunteers will facilitate that. We have a code of conduct, as do all PyData events. We expect everyone to abide by this code of conduct and appreciate your participation there as well. And you can see here the names of all of our core committee members. If you have any issues with the code of conduct or anyone's conduct, please come see one of us. So next, I'm going to hand it over to Denny to talk about our sponsors.
Thank you very much. I won't bore you with too much details, but I was told that I was supposed to speak for about 30 minutes. Is that okay? No, I'm completely joking. So if you don't know who I am, which is fine because I'm not that popular, my name is Denny. I'm here to represent Databricks, and I'm also a maintainer of the Delta Lake project, hence the reason for the logo. Am I blocking it? I think I'm not. Okay, good. All right. See, I actually have to go ahead and have a list of things to remind me what I'm supposed to talk about, which the first point was to include my name. So I did that part. That's good. All right. If you also don't know, I'm also a co-organizer with Eloise here for the Seattle Spark and AI meetup. So we have run lots of cool, fun events. And so, yeah, and that's why we're actually here today. When we're talking about like the past, current, and the future of programming languages, a lot of us are going to go right into the geek side of the house, and that's okay, by the way. I'm actually happy for us to go ahead and do that. But the reason and of course, the fact that we're also going to be benefiting the Last Mile Fund, we're going to be benefiting NumFocus, these are all great things for us, okay? And that, again, why we at Databricks have been very happy to sponsor this event, all right? But I also want to talk to you today, not just as a Databricks employee, but also as just a fellow geek, okay? So I'm just gonna ask you to raise your hands. How many of you guys are, and gals here are geeks? Like, in other words, you consider yourself programmers. Excellent, okay, so we've got the right crowd. I'm really happy to hear that, all right? So now I'm gonna betray the fact that I'm actually much older than I look, but basically, for these people here, they've actually had a massive impact on my life, though they don't know who I am, and we've never talked to each other, okay? So, for example, if I was to go ahead and start with Anders, okay? After using an Apple IIc and Apple IIe, I don't know if anybody knows that particular device, okay? I went ahead and was programming in BASIC, of course, but then I swiftly switched to Turbo Pascal. Awesome. There's debugging, there's monitoring, there's this beautiful blue screen in the back to debug. Awesome, okay. So that's how I got into programming. It allowed me to break out of my shell and start communicating, because some of you, I'm not gonna generalize, but I was a very horrible communicator. I could not talk to people. I basically would rather stare in front of a screen and actually geek out. But geeking out allowed me to actually open up and talk to folks. And then we talk about Java, of course, super important. So if you know me at all, a little bit, then you know that I'm part of the Apache Spark community. And of course, the fundamentals of how we built Spark is based on the JVM, right? So really, really cool. So my career path, in terms of how I went ahead and built up the career that I have right now, is fundamentally based off of the Java programming language. Pretty sweet, cool. I did also want to add, Guido's right there too. Don't worry, I haven't forgotten about you, okay? So I am wearing a nice Python shirt because that is what I've switched to now. Not because there's anything against the other languages, but because it is the lingua franca of the machine learning, large language models, AI, all these other things, okay? The reason I'm bringing up the story isn't just to go ahead and chat about myself and take up too much time, though I probably have done that too, okay? The reason I want to bring that up is that every one of you has a story like that, okay? May not be the exact same one that I have, but we're all here today. We've lived the lives that we live. We have careers that we're building up because of the programming languages that these creators have created. So that's why we're really happy, Databricks and Delta Lake, to be sponsoring an event like this. This is the inaugural event, obviously, but the point is we want to continue doing this because this is a great way for us to celebrate the careers, the technologies, the advancements that we currently have today. So thank you very much for giving me the opportunity to speak up here. Thank you very much for creating these languages that have built up my career, and I appreciate your time.
Thank you, Denny. And I'd like to welcome up a couple of our other sponsors. First, David Aronchik from Expanso. David, are you here? Okay, we'll give him a moment. Dawn, do you want to jump up and talk for a moment about your time? Thank you. And then you hand it off to Pierre. Thank you. I can keep that, actually, maybe. Yes, there you go.
I think there's slides.
Oh, are there? Yes.
And then one more.
I'll stop being controlling and let you.
How's this work? Hey, hi, my name is Don Chu. I'm a GP of Aperture Capital. We're very proud to support this event in support of Last Mile Education Fund, NumFocus, both organizations that are very dear to our mission. And also, thanks, of course, to our creators, and Carol Willing, who's a big role model for me, of all she's done for the open source community. Our fund is an early stage fund that invests in chunks of 100K to $1.5 million. We also have a second bucket of capital with our good partners that writes checks from 3 million up to high 8 figures. A lot of our deal flow and everything comes from my activity in participating in events like this for the past decade or so. And a lot of our founders represent that as well. And particularly, all of our founders are coming from highly technical backgrounds who are committing really cutting-edge software. And all of them are dependent on everything that James, Anders, and Guido have done, and they're big role models for them. And what we try to foster with our portfolio is an openness to the open source community. Several of them have open source projects or are major contributors to open source projects. And then, of course, up in the upper left corner, there's Anaconda, which professionally has some relationship with Anders and Guido with the recent announcement of Excel's integration with Anaconda, bringing Python to possibly 1 billion users, which I think it's really exciting, and we want to congratulate Guido and Anders on a project that took a long time, a lot of work, and we're proud to roll out the power of computing to a lot more people, and I think you'll find out that everybody here on the panel, they really care about expanding that reach and delivering some really great results to humanity through technology. So thank you very much.
We'll come back to that, John. Thank you, everyone. Thank you for being here today. I wanted to focus, I'm not a geek. I used to learn Python and R during my Master of Research in Decision Sciences, but people who know me, they know me also for being a civil engineer, which is not very relevant to the crowd here. But I tell people that I used to build bridges, and now what I'm trying to do with Notable as a company is really build bridges between people. And so I was just going to focus 30 seconds on why programming languages are actually building bridges between people. And something we have been trying to focus on this week, Anders is bringing the TypeScript server side into Jupyter Notebook. So it's done. We did that yesterday. So you can go try to use the Dino kernel in Jupyter Notebook, which I think might be fun for some of you if you wanted to use TypeScript in Jupyter Notebook. And so yeah, just a quick announcement about that. And thank you everyone for being here and helping bridge the gap between people with different programming languages.
Can you, oh, did you rewind it?
I rewind it.
Yeah, I saw you trying to do my part. I saw that. Nice try, Pierre. Hi, everybody. My name is Josh Ayala. I'm the CEO of Perfect Day Games. If you told me 23 years ago when I was starting out as a full-stack engineer that I would be up here today with these coding legends, I never would have believed you. And so it's a big, very exciting day for me. Are you guys excited? Yes, yeah, okay. So really stoked to be here and see all of you. We, at our company, we make video games, and Don has been connected to the Python community for a long time, and he has this story about an old, I'm gonna emphasize, or like probably be hyperbolic, but I'll say a ratty t-shirt that that Guido had that was similar to this. And so the spirit of it is kind of, it's a spiritual successor to a t-shirt that Guido wore in the past that was promoting the concept of women can code too. And so I loved that idea. I loved that concept. And Don said he saw this character that's a character in our video game. Her name is Rhea. She's a roboticist. And he saw this and said, this would be a perfect fit to recreate that t-shirt. And the idea, of course, was, I was instantly sold. But most importantly, at Perfect Day, our values are around having the widest diverse team that we possibly can. That's really what I believe is going to make the best products that will speak to the most people, and how we will have the most fun. And hopefully you got to interact with some of our team members who are volunteering here today. But I want to encourage you to get this limited edition t-shirt. How many of you got one? We can do better than that. I say, please go buy a t-shirt after this event. We'll have them out of the front desk. There's a QR code that you can scan. And this is, like I said, this is a historic day. It's a limited run t-shirt that's tied to today's event. And we appreciate Python partnering with us and letting us make the logo so we can keep raising funds. And lastly, I'll just say I'm so passionate about trying to get these engineers through school, which is what the Last Mile Fund does, and I think we have some folks in the audience that have benefited from the program, which just makes me so happy to see and know that our company will donate $2,500 both to NumFocus and an additional $2,500 to Last Mile Fund in addition to our support with the t-shirts. So really happy to be here, delighted that you're doing the great work, and we're just very excited to be supporters. And I'm just gonna ask a quick cameo. Guido, if you could demonstrate the t-shirt. My hands are full, so it's been too hard to pull. It's been too hard to pull this off my shoulder. You too could have one of these beautiful t-shirts and look as handsome as Guido does today. So yeah, thanks again for coming. Thanks for letting me talk and be a part of this. Who's next? There you go.
Thank you, everyone. Thank you for being here with us. All this event, as Ruth said, it was made thanks for volunteers. 100%. All of us are volunteers for this noble cause, which is NumFocus. And the Last Mile Education Fund. And I would like to talk to you about NumFocus. We are a nonprofit who develops all these libraries and software that you probably use if you use Python. And also we develop libraries and support software for Julia and R. So thank you so much for being here. Just with your sole presence in here, you are supporting these two nonprofit, this charity event. And with that, I'll let you with Ruth. Thank you so much.
Okay, I'm going to just share just a little bit about the Last Mile Education Fund. I can talk about it at length, so please talk to me later. I have spent more than 20 years trying to increase diversity in technology and engineering, starting out at the Girl Scouts back in 2001. Created many programs, and one of the problems that I identified around 2017 was really great, striving, amazing students were stumbling in the late stages over really dumb things, like a car repair or getting sick and missing some classes and having to take them over. Small costs at the late stage that were derailing students who had invested years in becoming engineers. So I did some research, and it turns out if you just look at women alone in the United States at any given time, there are 76,000 women studying computer science or engineering in their last 4 semesters who have a family income under $51,500 a year. Which, by the way, that is considered 200% of poverty in the United States of America for a family of 4. So imagine when your car breaks down when you're a senior in college and you're trying to juggle 3 jobs and do your classes and study for technical interviews. That can be devastating. And so in 2017, one of my long time students who I had been watching since she was a senior in high school, no safety net, both parents in and out of incarceration and the corrections system, really challenging childhood and problems, but she'd made it to her junior year in software engineering at Mississippi State University. So a black woman in computer science, exactly what we're all trying to achieve. And she had a confirmed internship at one of the big banks. And she almost canceled it because she could not afford bus fare from Mississippi to North Carolina or a place to live until she got paid. That is stupid. That is legit stupid. So fortunately, I knew her and I had lots of air miles and I flew her to that internship, found her a place to stay. Today she's a vice president of information security. She's a homeowner, she's a mother, she's been in her career for 5 years. She is also the co-founder of this fund with me, along with her professor, and we launched in 2019 to solve this problem at scale. We have now funded 6,600 students, women and people of color across the United States in computer science, engineering, and now we just recently expanded into semiconductors. And shockingly, it's an average of $1,000 per student to make this change. It is so cheap. So work for a company that matches. We're on Benevity at Microsoft, at Google, at all the places. And obviously we take donations to our website. You can buy t-shirts. All of these things benefit us, but trust me, the smallest amount of money, and we do have a grantee here, Brenda, who recently graduated from UW. And many others. The other thing I'll end with is that our grantees are, here's my numbers, I'm very proud of these, 41% Black, 22% Hispanic, and 63% female, all within 6 to 18 months of graduating. So like, if you're hiring, come talk to me. I want to also introduce a young man that is here. Okay, ignore that part. Yes? At the end. Okay, sorry. I'm going to take you through the programs. We have attendees checking you in up front, opening remarks, okay, that's me, discussion panel, and then our closing remarks and photos at the end, so there'll be lots of opportunities for photos. I also want to mention that previously we had Elle Goldberg on the agenda, but unfortunately she had a medical thing come up and hasn't been able to travel here, but she really wished she could be with you, and we're hopeful that we can have her next time. Okay, I want to thank our event committee. We're all here, Stand Up Event Committee. We have been meeting every week for an hour for months. Thank you to everyone, Pierre, Josh, and especially Elo, who has done so much work and done all the logistics. And I'm up there, and Don, of course, you met earlier, and Mike Miranda, where's Mike? Way over there, he's taking photos. Thank you, everybody, for all of your time and help to benefit us and put this event together. And, okay. I am excited to introduce Antonio Glenn. We wanted to have just a little moment of the future, and Antonio is doing his PhD in computer science at University of Washington and working on mobile health technology, and he's going to share a few words about how he feels like programming languages helped get us where we are and are going to get
No, I think it's fine. Oh, the next one? Okay, perfect. There we go. It's just one slide, so it's fine. All right, well, thank you for the introduction. Hello, everyone. I want to thank the hosts and the conference organizers for allowing me to say a few words to open this panel. It's also a great privilege to be here to give just a little bit about my personal experience in software and programming. I want to tell you all about my path to computer science, my interest in engineering, and a lot of the observations I've had along the way. And then I'll end with some of my thoughts on the future of software technology and technology in general. Ever since I was young, I've enjoyed taking things apart. I always got a kick out of seeing how things worked, and there's really no better way of doing that than pulling out a screwdriver and hammer and breaking things open and looking how things work on the inside. Whether that be an old speaker, television, remote controller for an RC helicopter, seeing what gave life to so many of the gadgets that we use in our day-to-day life has always been exciting, even if I didn't fully understand the details of how they worked. But what mattered most, what mattered more than knowing the details of how all this technology worked, I think was the curiosity that this endeavor nurtured in me, and likely in some of you as well. Cutting wires, breaking things open, shorting a few circuits here and there, and causing smoke to spew out all over the place. This is how I went about understanding things, how I learned about understanding the technology that I used in my daily life. And as it turns out, electronics weren't the only thing that I had an interest in understanding. Human physiology and medicine always fascinated me as well, and so I decided to study biomedical engineering in college. But what was really exciting in this field was learning about the inner workings of medical technology in particular. Whether that be the imaging technology that lets us peer inside of ourselves with such captivating detail, ventilators, anesthesia machines, the vaporizers that produce the cocktails that allow us to go to sleep for surgery, or the instruments that diagnose a whole range of human ailments and disease. All of this technology I had seen on television or in use with my own eyes, and it's really what drew me to study biomedical engineering and the field of medical sensing devices broadly. Now, because I was in the School of Engineering, I also had to take an intro programming course during my freshman year of college, and I was taught a wonderful little language by the name of MATLAB, and I actually have some very fond memories of my early experiences with MATLAB. For beginners, it definitely makes learning programming quite painless. The installation was pretty simple, as easy as downloading any other app on your computer. There's immediate feedback when you're working at the interactive command prompt, and I could inspect all of the variables and things that I was working with. Of course, there were naturally some hiccups when using a proprietary toolkit such as MATLAB, like when your license key expires the night before you have a major deadline due, which happened to me a couple of times. But because I was still a neophyte in the realm of programming generally, I thought that I had rather high, I thought highly of the entire sort of MATLAB ecosystem, and the fact that I could now call myself somewhat of a programmer. But in my experience, the hardest part about learning MATLAB actually is, at least in the beginning, is when you are inevitably met with ridicule from other computer science students when you tell them that you use MATLAB. I'll never forget going to my first hackathon, opening up my computer, booting up MATLAB, and someone just coming behind me and whispering, "Are you using MATLAB for this?" But nonetheless, MATLAB got me through my biomedical courses, and because I'd never had a traditional computer science education, I never really questioned much of MATLAB's design choices or the premise behind MATLAB as a tool in general. I just took its suite of tools, expensive license, and the fact that you couldn't easily change the IDE to dark mode for granted. And while MATLAB definitely has its use cases in engineering, eventually I developed a love-hate relationship with it and came to find that it was a stifling tool to use for a lot of the other types of programming things I wanted to do. I slowly started realizing a lot of MATLAB's shortcomings when I began using Python. I remember my first exposure to Python pretty vividly. It was with the book Python Crash Course by Eric Mathis from No Starch Press. I came across this book during the end of my junior year in college when I was studying for finals. And I had always heard this word Python being thrown around a lot by some of my CS friends, and I knew vaguely that it was a programming language. And since I was starting to get frustrated by some of the workflows in MATLAB, I thought I would learn this other language as well. And so I coughed up 40 bucks and decided to learn Python with this book. And I think it's fair to say that in retrospect, this book and learning Python in general really was a turning point for me in my computer science education and my relationship with programming languages. Not only was Python, in my opinion, a very beginner-friendly language, but it also has really beautiful aesthetics and a powerful versatility. I could be using NumPy and SciPy to compute Fourier transforms 1 minute and the next fire up a web server and work on my personal website in Flask, or use CircuitPython to teach high schoolers how to program microcontrollers. So incredibly versatile language, and I loved it. And what makes it and so many other open source languages like it is precisely that fact, the fact that they are open source, that you can peek inside and examine all the details to really understand what's going on. This feature of not only open source languages, but open source projects in general is really what gives them a lot of their appeal. The curious can open the lid and understand how everything works from the inside. As it was with the hardware of our youth, so too we can observe the inner workings of the software that powers so much of our digital world. And this is an empowering act. And a natural consequence of making a language open source is that you'll attract a natural community of developers who want to build off of it, people who want to contribute to the maintenance of the tool for others to tinker with, to break open, and to also further explore. And the idea of giving people access to the insides, giving people the keys, so to speak, to this technology, is what made the open source community so engaging for me in this journey. I've taken to teach myself computer science and programming, and this level of accessibility and openness is really what has skyrocketed many of these languages to quite dizzying levels of popularity. But one thing that also attracts me strongly to the open source community is the participation that it fosters, to actively shape and maintain something that you and your fellow comrades are working towards, and many of whom you share common goals. And so I want to talk now about some of the work that I've done so far during my PhD and its particular relevance to the open source community. So the most recent project that I worked on earlier this year, we published, was a device that could perform low-cost hearing screening. And early hearing loss screening is very important to make sure that newborns can obtain appropriate medical care at an early age and can also develop assistance for cognitive development. And in the United States, virtually every newborn undergoes hearing loss screening at birth. But unfortunately, the device that performs this test is incredibly expensive. It's thousands of dollars. Despite the fact that the mechanism of operation is surprisingly simple. All it does is play a series of tones into your ear canal, and it just listens to the frequency content of the signal that comes back. It doesn't even require any visual or active participation from the newborns. So it's completely passive. And so to overcome the high costs associated with devices like this, we built a wireless earbud that could reliably perform this hearing loss screening using just commercial off-the-shelf components for less than $50. And so the entire time I was working in this sort of space and on this project in the field of medical sensing, you often hear words about democratizing healthcare or empowering patients through ubiquitous technology. And this type of language has also been extended to things broader than health sensing and medical care, like expanding access to tools like ChatGPT or large language models. But what does it mean to democratize health or to democratize, say, blank or whatever? To me, it usually means something along the lines of making devices that monitor our health more widely available, or making technology cheaper or more easily distributable via downloadable apps, for example. And lately, I've also heard this type of language be used in the context of large language models, for example, giving patients access to their own sort of personal healthcare provider in your pocket, or students giving students access to their own sort of personal tutor in the spirit of democratizing education. But in my opinion, through many years of shadowing physicians and healthcare workers working in the field of health sensing, and also just observing the current state of technology and the structure of ownership in the world today, none of these things really democratize technology or health in and of themselves. To be sure, making impactful technology cheaper without reducing its quality is a good thing. and as are reducing the barriers to technology access and healthcare access broadly. But I think to democratize something is a much harder thing to accomplish. It means giving people the ability to participate in the decision-making and in the conversation about how resources are distributed and what problems are actively being worked on. Strapping new smartwatches onto your bodies to track your health vitals around the clock, or chatting with a large language model whose inner workings and training data are hidden from the users will do little to democratize health, education, or technology, in my opinion. And there's a good article by Francois Chalet, the creator of Keras, where he says that technology is never neutral. If your work has any impact in the world, then its impact has a moral decision, or a moral impact. And technology is never neutral. We need to bring the people whom technology affects to the table in order to shape how it's created, how it's distributed, and how it's used. And so without any talk of allowing users to actively participate, any talk of democratizing X or developing the next greatest technology to improve humanity is immediately a non-starter. And this is where I think the principles behind the open source community are particularly instructive. The success of the open source community, itself a form of democratic participation, is remarkably instructive in teaching us how to structure our lives and the technology that we use. I can't offer you many strong opinions about the details of how a programming language ought to be designed, or from an engineering perspective or computer science perspective, nor can I pontificate on the future of programming languages generally. But I know that if we're looking to technology in order to improve our lives, then we need to allow people to participate in the decision-making, and that must be the guiding principle. It is the only way to a sustainable future of technological growth. As it goes for open source, so too it must go for everything else. And I think it's fair to say that the work and the creations of a lot of these talented developers and engineers who join us today, I think they were driven a lot by this mantra of openness, of accessibility, of engagement with fellow collaborators in the community at large, ultimately with the goal of improving the lives of others through collaboration. They were likely not driven to create such groundbreaking technology with the hopes of sealing it off and monetizing it for an elite few. And so no matter what future languages we use, or whether AI and LLMs make programming obsolete or visits to the doctor's office unnecessary, I think that active involvement by large swaths of users should be a fundamental principle behind any piece of transformative technology that can affect people's lives. And so, as the saying goes, nothing without us, about us without us. Thank you.
Okay, thank you very much for that. Okay, and without much further ado, I am very excited to get us started with our celebrity panel. And to kick us off is the esteemed Carol Willing of Jupyter, who will be asking our questions. There will be an opportunity later for audience questions, so be building your questions in your heads. That will happen kind of towards the second half. Take it away, Carol.
Thank you, Ruthie, and welcome, 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 everybody, for being here. It is really exciting and going to be quite an adventure with the 3 language creators that we have today. So I want to welcome everybody to the PyData Seattle's 2023 Language Creators Panel. I am Carol Willing. I am a Python core developer. I'm also a Jupyter core developer. So if any of you have used Jupyter Notebooks or Jupyter Hub or Binder, I had a part in that, as well as becoming part of the team that got the 2017 Software System Award for Jupyter's impact on interactive computing with data. And so what I would like to also say is I was recently the VP of Engineering for Notable and just retired, and am able to now follow my huge passion, which has always been helping people learn how to program, helping people communicate their ideas, and to really fabricate their ideas. And without any further ado, what I would like to do is have all of you be participants today. So start thinking about the questions as you hear the language creators speak today, of what you're curious about, what you would like to ask them, because we learn from all of you. Whether you're a complete beginner or an expert, your opinion really helps guide where we go with these languages. So first off, I'm gonna introduce the panelists by the order in which I use their languages. And I've been around for a long time. I started programming in 1977. So I would introduce Adele Goldberg first, but she was unable to make it here. But she will be in here in spirit because Smalltalk, the language that she created, really helped with the foundations of object-oriented programming, graphical user interfaces, and interactive computing. And we hope to have her in the future. But we do have here today Anders Hejlsberg, who was the creator of a few languages: Turbo Pascal, Delphi, C#, TypeScript, and he's working on a cool new project that I find interesting called TypeChat. So please join me in welcoming Anders Hejlsberg to the stage. Thank you, Anders. Yeah, go ahead, take a seat. I might bite, so choose your seat wisely. The next person that I want to introduce is the esteemed James Gosling, who is the creator of Java, who, as a language, helped me bring joy to programming with threads. He has also worked on all kinds of software, including the original Unix IMAX. So please welcome James to the stage. And last but certainly not least, Guido Van Rossum, who is the creator of Python, a language that has touched so many different areas of society, people, and really empowering people to use code. And so with that, I would ask Guido to come to the stage, and please welcome him as well. All right. So as we kick off, where should I sit? I guess right here. We've got a 2-hour time block, and we're going to use it wisely. So I'm going to start off by asking each of the panelists some different questions. I am hoping, like last time, we were able to make it very interactive and really have a discussion between Anders, James, and Guido, and all of you as well. So to start us off, I want to ask the creators, and I will start with James on this one. What was the first programming language you created, and what problem or need motivated you to do so?
Depends on what you call a programming language. The first thing that involved like a parser and code generation was an assembler for PDP-8 machine code. I was motivated by the fact that the one that came with the machine sucked. That is the technical term. Worked well, satellites flew, because I had a day job, right? And building the assembler was just so I could get my day job done.
That's often a good motivator for getting something started. What was the motivator for building Java?
We were doing an IoT project.
Okay.
And we were working with a bunch of companies in Asia and Europe and the US. We had been talking to them about, what their concerns were, and we were building prototypes in C and C++, but kept running into problems that were kind of around, well, there were a lot of issues, security issues, reliability issues. One of the things about IoT programming is if something goes sideways, a human probably gets hurt.
Absolutely.
And as somebody who at the time had spent a decade and a half writing C code and debugging memory allocation problems, and all kinds of memory corruption, smashes, and all that kind of stuff, it became really clear that this was not going to fly. So it started out with trying to make C safer, and then it kind of got out of control.
It's Java has grown tons since I first started using it, and it's really been just a great foundational thing for mobile and other interactive devices as well. Anders, what's the first language that you created and why?
Well, that's got to be the predecessor of Turbo Pascal, which at the time I was in Copenhagen, and I was at university there, and I had started a company with some buddies I had met, and we were selling 8-bit computer kits, and they were based on a Z80 back then, 64K of memory. I mean, if you could afford 64K. And they came with, this was a British kit computer called NASCOM, and it came with Microsoft ROM Basic, an 8K ROM in it. And of course, that was what you had. It was either that, you could code in that, or you could code in machine code. So most people coded in BASIC, but it was kind of slow and kind of shitty, And
Yes.
And I had been taught ALGOL. That was my first programming language, and then, I wanted to create a better programming language, or compiler, or whatever. And my buddy was, there's this new thing called Pascal. You ought to check it out, And so I built a very small implementation of Pascal, a little compiler, runtime, and on-screen editor. And that fit in 12K of ROM. So you could yank out the Microsoft ROM Basic and stick ours in, and then when you turn the machine on, you were sitting in a little on-screen editor, and you could type in programs and compile them and run them. Of course, to squeeze it into 12K, you had to write it all in machine code or assembly code. So I became pretty good at writing assembly, and that then grew into later to implementations of Turbo Pascal, and it wasn't really until the 32-bit version that we switched to coding the compiler in C. So the 8-bit and 16-bit versions were all hand-coded in assembly.
Oh, wow.
Yeah.
That I never realized. And Pascal was one of the languages that I remember as being sort of user-friendly at the time relative to BASIC and Fortran and certainly C. But that's fascinating.
Yeah, it was also implementer friendly.
Yeah.
In that you could actually implement a one-pass compiler. There were no forward references. It was fairly simple to write a compiler for it, and so that was part of what helped as well.
Cool. So let's fast forward a few years or a few decades, and what prompted you to write TypeScript?
Oh yeah, well now we're jumping ahead quite a few more years. So the start of the genesis of TypeScript probably goes back about 12 years ago. And this was at the time when finally the web platform was growing up. There was this big shift happening where it was going from a heterogeneous world or homogeneous world with all PCs to a heterogeneous world with devices and all sorts of different form factors. Google had created the V8 engine for JavaScript, and so all of a sudden JavaScript was actually becoming performant, and HTML5 was happening, and so there was actually a reasonable UI model that you could code to. And so people were starting to write really large apps in JavaScript, and they were having a very bad time doing it because JavaScript is a language that has lots of issues, and in particular it doesn't have a static type system, it doesn't have any of the stuff that makes it possible for you to write good tooling. And so we were seeing people do crazy things like write their apps in, say, Java, and use GWT to translate it into JavaScript, or write in C# and use a tool called Script Sharp. And they were doing this just so they could get good tooling. And then they were sort of treating JavaScript as an IL, just a compile-to language. And I was like, wow, is it really that busted? And is that really the best way to fix JavaScript? How about we actually fix the language itself, or fix the tooling, or look at what is it that's broken? And then let's try to fix it. And that was basically what led to TypeScript.
Those are good motivations for creating a language. And Guido, what was the first language you created?
I remember when I was in college, I got a part-time job at the systems group of the mainframe that was running most of the computer services for both universities in Amsterdam, actually. And I had fallen in love with that mainframe already and learned Pascal and Fortran and Algol. And I got a job at this systems group that did sort of programming tasks related to the operating system. There was a control data mainframe, and there was a job control language that was very simple. Basically, read one card, execute the job that that card described. And what we realized was that we needed control flow, or at least it would be useful for users to have control flow in the job control language. And there was something very primitive that basically would let you fast forward, skip some cards in the job control block of your input deck. And there were primitives for that, and with the encouragement of my manager, I wrote a small programming language that was itself implemented as one job control step that would sort of parse its command line as an if or a while or a go-to or a variable assignment, simple things like that, and let you manipulate the job control that way. And so users were creating complicated branching and even looping structures in job control using that thing. I think it was called POP2. There must have been a POP1 that was even more primitive, but that wasn't mine.
So let me ask you, and maybe set the context for that time. It was a bunch of punch cards. So you had typically, when you wrote a program, a bunch of cards in a shoebox or something, and if you dropped it, it was a very unfortunate event, especially if you didn't number your cards. But my understanding is you created something that then let you the computer skip which cards, like some of the cards in between others, based on the control.
Yes, of course. At that point, the cards were already virtualized.
Oh, well, that's nice.
Because the sort of the way the mainframe ran its jobs, it actually would read all the cards onto disk and then sort of interpret them according to the rules of the operating system. So it wasn't literally moving cards back and forth in the hopper of the card reader. That would have been something.
Well, I was very impressed, but I'm equally impressed with the virtualization. And what prompted you to create Python?
Well, I'll have to repeat what the other said. That fast forward quite a bit. I had developed a variety of other software, managed to graduate, which was not totally a given at some point. Got hired to work on a programming language that was actually very influential. It was initially called B, then became ABC, and then the project got canceled. But during the 3 or 4 years that I worked on ABC with a team of like 4 or 5 other people, I learned a tremendous amount about user interaction, programming language design, programming language implementation, philosophy of programming language design. I mean, my mentor was the sort of original designer of ABC, who was a marvelous man and could talk very eloquently about why every feature of ABC was designed just the way it was. Then after ABC got canceled, I ended up in a different project where we were working on a distributed operating system, a microkernel-based, network-based operating system. And I was part of the group tasked with writing utilities for the operating system so that users could actually log in and sort of run a shell and do the things that you did by that time in an operating system, like what you're used to on the command line of Unix. But in Amoeba, as the thing was called, everything was sort of reinvented from scratch with a networking philosophy built into the utility. So everything, we couldn't just port the Unix utilities, we had to invent them on the spot. Everything was written in C, and I realized that our productivity was kind of slow because, as James pointed out, C is a language with lots of sort of difficulties, especially related to memory allocation and debugging issues around that. And so I thought, oh, if only we had a language that took care of things like memory allocation and a bunch of other things too. And now there was a sort of minor leadership vacuum where the principal engineer on the project was on a sabbatical for a year. And he told the rest of the team, yeah, just keep doing what you're doing. So I didn't. And instead, I implemented a language that sort of did what I wanted, and it was very selfish. I wanted to sort of prove that it was possible to create an ABC-like language that was actually successful in a Unix environment for people like myself who were sort of at least 8 hours a day professional software developers. And I don't know, some kind of luck of timing and making it open source when we did made it fairly successful.
That's awesome. And you know, there's so many changes from when, let's say, the early 90s, when a lot of this stuff was getting formulated, to now. We had some things that were constant. We had data back then. Change was a constant. We had constraints. Now, if we fast forward to today, what do you think are some of the things that have changed most when it comes to language design based on where we are in computing today? And I'll start with Anders. I told you I would give you the easy ones.
Well, I mean, I think, first of all, I think it's important to understand that language design evolves very slowly. There's not really a huge fundamental difference between the languages that we use today and the languages that I started implementing 40 years ago. Pascal is not that different, say, or Algol or Smalltalk or what have you from what we do today. I mean, there are a bunch of things that have happened since or that have influenced language design. We certainly have learned a lot from functional programming that we've even managed to incorporate into mainstream languages. I think probably the biggest change I think that has happened is, I mean, just the capability and capacity of the hardware that we use today. It's astounding, right? I mean, you look at I'm probably 6 orders of magnitude more capacity and performance than there was in computers that I started with 40, 50 years ago. But it's not as if our brains have grown by 6 orders of magnitude and whatever. And programming is very connected to the human mind. and we have not evolved at all on that same scale. So there's like a big gap sort of that has opened up there, where it used to be that everything was capacity constrained, and that was really what guided your programming, right? I mean, and that's why people would write in assembly and what have you. And now it's, for all practical purposes, computers are just like black holes of there's just infinite amounts of capacity in a sense, right? And it's become much more a game of leverage, of not starting from scratch, but rather, you know, leveraging work that has gone before. And that's why I think open source has been such a wonderful thing for the world, because we can all stand more on the shoulders of giants than we used to be able to, and then actually invent new on top of that. So I think that has been a complete fundamental change in how we program now. But it's sort of, it's this odd amalgam of something that hasn't changed a whole lot, and then on top of hardware that is so fundamentally evolved, right? That yeah.
Yeah, and I mean, the hardware has changed a ton. I mean, I remember like trying to fit something in like 128K memory things, or very small hard disks, or before that, floppy disks. And James, you've been really involved with the hardware side of things. What changes have you seen?
Well, in some sense, kind of the same stuff, right? I mean, it's the big drama has been in scale, right? And scale in the number of processors, scale in the amount of RAM, scale in communication, and those three alone, right? I mean, building software that exploits all the processors on a machine is really tough. But you know, people do it every day, and that's kind of one of the core things in Java, was all the multi-threading support, and having multi-threading support in all of the libraries all of the time. And you know, the kind of RAM that's available. I mean, the first machine I used had 4K, right? And now, at least at AWS where I work, anything with less than a terabyte is a little baby machine.
Oh my goodness.
Right? And people are running lots of apps that are in, you know, with multiple terabytes of RAM. And they're doing these high rate transaction systems. And keeping the data structures straight, keeping all of that consistent, building these complex graph data structures that I remember visiting a customer once that had the circuit diagram of Great Britain in RAM, right? And they were using that for live diagnostics.
Wow.
And it's like, okay, cool, right? And then you take all of that and you spray it across networks. And the way you have to think about programming on a network. And you know, one of the things that always gets troubling for me is that people don't appreciate the difference between like a method call in a programming language and a network call, something that where you make a call across a network to do something, right? So people, you know, these concepts like microservices. Microservices are generally a good idea, but you know, a microservice invocation is about 1 million times slower than a method call. Now, I don't care what cloud structure you're on, it's at least 1 million times slower. And sometimes performance actually matters, right? And so when people come up with microservices, it's, you know, often they don't make the engineering trade-offs. It's more of an org chart kind of trade-off, right? And being able to build tools so that you can balance off this dramatic growth and take account for all the different changes. And you know, some of the things like in these huge memory machines, you know, the memory access performance is not uniform, right? The different
Right.
bits of RAM are at different distances, and man, getting all of the low-level machinery so that all gets taken into account, but developers don't have to know about it. That's a big deal.
Right. There's been so many changes. Guido, what are some of the changes you've seen over the 30 years with Python?
Well, I would go back even further. So when I started my career on that big iron mainframe, the sort of the attitude was the software development team sort of existed in service to the computer. It didn't matter how long it took the programmer to write the code, or how difficult it was for the programmer to write the code, because it was sort of economically viable to have a room full of programmers develop a piece of code that would then run on the mainframe to make it a few % faster. That still exists in James' context, for sure, but what we've also seen is that a lot of times if sort of computers are cheap enough that the time of the computer is much cheaper than the time of the programmer, and so languages and tooling have started to come about that sort of prioritize the ease of doing their work for programmers and often non-programmers who are using computers. And so I think that is one of the big changes that I've experienced, where, and Python was still sort of, came about when it wasn't so clear, when most people were writing code in C because they wanted their code to run fast. And they would spend a week optimizing a piece of code that would then run in 1 minute instead of 1.5 minutes.
Yeah, well, you were talking about sort of processors being cheaper than people, and that's a mindset that has ruled a lot of industries, right? That it's really good to optimize human time, but where people get caught up is is that when the business scales up, that balance can shift, right? So it's like, okay, we've got this thing that's running on one processor. We can run it on a much beefier processor.
Absolutely.
But then all of a sudden, okay, we've got to run it on 100,000 processors. Then, man, 5%, 1%, those things start to matter, and it then, it's not like doing the rapid development at the beginning was a bad problem, but it's just that the software always has to evolve.
I think that's a really good point, and I want to loop back to a few different points. We've talked about the scale of data. We've talked about the need for change. One of the things that we create languages for is people. And like Anders said, the cognitive load has gotten more and more over time relative to the brains that we have. I mean, I can remember in the early days going, and the way I would get information was to find a magazine, flip through it in the library, and then type the code line by line into whatever system I was using. Today, our audience members there's a fire hose of information that comes at them every day. Guido, how do you stay on top of the things that are important, or what would you suggest people think about as they look at this fire hose of information?
Those are two very different questions. What I personally do is I ignore everything until people I personally know and trust keep telling me, oh, you gotta look at this thing. Oh, hey, ChatGPT. What is ChatGPT? oh, check it out, you gotta watch this video. I don't know what strategy would be best if you're sort of interested in staying abreast of all that, that fire hose. You gotta sort of pick something and stick with it for a while. You can't be distracted by all developments everywhere.
Yeah, learn to accept failure. it's okay to be, imperfect.
I think that is a great comment that is understated most of the time, because failure is how we experiment and move forward and innovate. Anders, any thoughts on how to keep up with the fire hose?
Well, I actually agree with Guido in many ways. That I stay involved in day-to-day project this TypeScript these years, and through that you end up touching a whole lot of stuff, because people come with problems and they go, oh well, that's because they're using this framework. Oh well, what does that do? Well, that's because this and that is happening, and so you sort of get around that way. I like to read Y Combinator news too. I mean, there's always like interesting stuff that bubbles to the top there, and the discourse is interesting. And then of course, I mean, at Microsoft, you sort of, I mean, I've been at Microsoft for quite a long time now, and so whenever something rhymes with programming languages, I end up sort of getting involved, right? And so you end up touching a bunch of interesting problems that way, and you learn a lot about how other projects. And so yes, absolutely. Now AI colors everything these days, right? And so we're definitely learning a lot about that. But I don't know that I have a formula, because it is a fire hose, and you just cannot keep up with everything. And I think programming language design, as you'll probably understand from like our gray hair and whatever, it's a long game too. You can't just jump in and, oh, I'm going to do a programming language, and then 2 years later you're oh, now I'm going to jump to my new product. No. This is like 5 years. It's like minimum before, because and the ante keeps going up, because end user expectations are greater and greater on the tooling that people want. It's not enough to just create a language. You also got to create a runtime. You got to create a compiler for it. You got to create tooling and a language service, and you got to do this and you got to do that. And so package managers, I mean, it just keeps on growing. So for us, it's like, yeah, I mean, each project I've been on, it's been at least 10 years, right?
So, staying on the topic of people, people tend to have opinions, and open source is I think one of the things that we agree drives languages forward. James, what are some of the challenges that you faced with having a language and maintaining it over all of the years when it comes to actual interactions in open source?
Open source is a developer community, the sort of things that revolves around most open source projects is relatively tame. When it gets to the point where there are large commercial interests that all hate each other who are involved, and you've got the whole alphabet soup of big tech companies who are all trying to vie for control of pick the tech of the day. That's not a normal open source project, right?
Absolutely.
That is big time politics, and I'm so glad I got out of that.
Yeah, you were in the midst of like quite a issue of that with.
Yeah. There was a lot of ugliness that went on, and there's kind of a tension in some of these between, like with Java, there was a real tension between the platform providers, the the digital equipment and Apollo computer and all the rest of them, they all wanted to own the entire universe, right? You know, and the developer community who wanted to be able to do whatever they wanted, right? And you know, there's kind of, you know, there are trade-offs. You can't make everybody happy, and you know, now it's much more. Well, it's much less political, much more sane. The actual end developers have a much bigger place at the table. Certainly the way that the Java community process works still has kind of a group in the middle that gets pretty ugly. But they're nothing like what they were 20 years ago. But you know, the fact that there are rules of the road, that everything is done in the open, that there are no backroom deals. A really long time ago, IBM was really pissed off because they wanted to make sure that the decision process was open and above board, and that there be some way to have an auditing company audit how a decision was made. And we went through all of this pain with an auditing company to figure out how to structure the decision process so it could be formally audited. Made that change, people were happy, except IBM, because they realized that they were the people who wanted the backroom deals.
Right. Any other thoughts, Anders, Guido, on this topic?
I think it's true. I think it's, I'm not sure I'd be doing what I do today if it wasn't for the whole transition to open source that we've seen over the past decade at Microsoft, and how fundamentally the power has shifted, you know, and the democratization of software, and in particular programming languages, and the whole development of how we build tools today, and the fact that programmers really get to vote with their feet every day, and it is a fantastic device for filtering out marketing crap and what have you. You know, it just doesn't work anymore. You are measured on how good your tool is, and open source is a fantastic device for measuring that, because people either use it or they don't use it, and everyone gets to try. And we were discussing earlier how I don't think it is even meaningful to think that new programming languages that are not open source will exist from here on out. Why would anyone bet their company and their investment on a language that is controlled by a commercial entity that could change the rules of the game at any point in time, and you have no recourse? I mean, as a programmer, that would suck, but it doesn't make business sense to do that either, right? And so that's really, I think, what has changed, because the industry that we started in, it was all commercial, and it was all closed source, and it was like buzzsaw elbows, and yes, and it is profoundly different today from what it was, say, 40 years ago when I got into this business. Yeah.
Yeah. Guido, any thoughts on this?
Well, there is, of course, there's open source and open source. There's the communists of the Free Software Foundation. There's the libertarians of the Open Source Initiative. There is sort of the pretend open source of certain mobile operating systems. There are things that sort of start incredibly open and sort of have a long tradition of being open that stay open. I want to mention Perl as a great example there too. There are also sometimes attempts at opening things up that were closed before because some commercial entity sees that there is a political or a business reason to play the open source game, but their heart isn't necessarily always in it. If you have a large enough company like Microsoft, you'll see all of the above at work at the same time. You'll see different things that name themselves open source. Maybe they're all hosted on the Microsoft corner of GitHub, and yet the sort of the processes that are used are very different. Some people sort of have a team that essentially uses closed source processes that pushes code over the wall to GitHub. You have other teams that really believe in open source and sort of have their decision-making process, their whole discussion forums done in an open source world. That's the kind of stuff that I like best.
Yeah, I mean, those are all really good points. And I think another interesting point is, you know, I took a long break in tech and, 15 years while I was raising my kids. And there's conventional wisdom out there that, okay, you can't do that. It's career limiting. You'll never be able to come back. And let's face it, life happens. People leave and, for health reasons or whatever. I think open source gave me, I think it was Java was sort of when I left, was the language I was using. And when I came back, really the only thing that changed was source control and Git versus RCS, CVS, SVN. And I think open source kind of gives people who wouldn't necessarily have the opportunity to participate in code for whatever reason, an option to do so. And I guess my next question would be, there's a lot of talk these days about low-code, no-code programming. And, should everybody program, or, should you make programming accessible for everyone? James, do you have any thoughts on that?
I don't think we've got enough time for that answer. Because, most of the low-code situations, things I've ever seen, they work really great on a narrow slice of applications.
Correct.
Right, they have very little breadth. And there are folks who have things that are kind of attractive things on the horizon, like all the Gen AI stuff. So public service announcement here, please stop using the terms AI, Gen AI, and ML. Instead say advanced statistical techniques. Because that's what they are, right? Understand that all of these things have probabilities involved. And, with generative AI, you often get very amusing things that are generated because they hallucinate. And people go, well, hallucination, it's a bug. We've got to fix that bug. The problem is that the hallucination problem in Gen AI is a deep, deep, deep architectural principle in how it's built, right? It's just trying to make sentences that kind of look like sentences it has seen before. That's all it's trying to do. It has no model of what counts as correctness. And the Gen AI that generates code, for my money, it's an attempt to eliminate the fun part of a software engineer's job and make the really tedious, hard part much worse.
These are all interesting thoughts, and we're going to come back to a bunch of those when we dive a little deeper into the AI stuff. But yeah. I'm with you on fun and exploration and experimentation. Guido, low code, no code. what are your feelings on that when it comes to language design or programmers in general?
So low code to me feels a bit like a marketing term, but I've thought a bit about declarative systems versus sort of programmable systems. And when the web first came around, it was HTML, which is a declarative system. And then it was quickly augmented with JavaScript, which is clearly a programmable system. And the intention there is that you do what you can using the declarative system because it is more robust and it's easier for the user. It can do one thing well and tooling can reason about it. But you have the programmable system attached to it that makes it possible for, say, advanced users or people who try to think outside the box of doing things that the declarative system wasn't built for. Because once you have a programmable system that's a programming language, it's Turing complete and you can do pretty much anything in it. And the whole point of the declarative system is to not be Turing complete, which makes it much easier for tooling to reason about it. You can't decide whether a particular piece of JavaScript will ever produce a result or not. But you can argue about how much space a certain block of HTML is going to take up. I think there's always going to be that tension where we try to analyze what our users are doing, and we try to give them declarative tools for all the stuff that they sort of do over and over again that is well understood. But we want to give them an escape hatch for when they're exploring boundaries where we don't quite understand what they want to do yet. If you don't give users that escape hatch, they get frustrated or they'll go to another system or they'll sort of invent their own escape hatch. Arguably, JavaScript was one of those. So I think where that goes with low code, no code is those are by and large declarative systems, and they need to be paired with programmable systems that give you people sort of a way to go beyond the capabilities of the low-code system. And it's not always possible to say, well, we'll design the low-code system to have sort of a surface syntax that's the same as the expansion language. I mean, there's a reason that HTML looks very different from JavaScript. And I'll stop with that example.
Well, so I'd like to add some stuff to that, because one of the things that has always struck me about sort of embedded kind of extension language things like JavaScript is they always grow 3 heads and become monsters. It's like an axiom of the universe. When on day 0 at Netscape, the whole reason for doing JavaScript was to do form field validation. I mean, I was there in the room, and you know, if you were writing something that was scraping web pages, you would get the web page. It would be a bunch of HTML, and it would be decorated with some JavaScript. These days, there'll be like an outer wrapper of HTML, then gobs of JavaScript code, and it will be pulling in text fragments from all over the place. So if you want to like scrape the web now, if you don't execute the scripting code, you cannot see the page, right? So the sort of low code, no code part of the web spec has been completely eaten by JavaScript. And JavaScript has become this thing that sort of pieces together fragments of stuff. And it's the sort of fragment assembly that is now driving. And it's just fascinating how many times I've seen that repeat.
Right. Anders, any thoughts? Because I know you've worked in a number of languages, including TypeScript, which is very close to JavaScript.
Sure. Well, first I'll echo what Guido said. But whenever I am asked to evaluate like the applicability of low-code, no-code systems, I invariably focus on what's the escape hatch here, because you always, with these systems, end up hitting a glass ceiling. And really, the thing that then ultimately decides whether you'll succeed or not is how possible is it to get out of the box and have someone who is a programmer solve some part of the problem outside that box. You know, and some of these systems demo incredibly well, and they are horrible at the escaping, and that can cause a lot of problems. So that's one thing that I've always sort of tried to look at. Well, with respect to JavaScript, I mean, yeah, JavaScript definitely had a lot of issues in its original formulation, but I will say it is actually a remarkably sound programming language at the bottom, you know, and Brendan Eich for having had 3 weeks to design it, luckily was a Smalltalk programmer and actually understood and a scheme programmer and understood, you know, the value of first-class functions and the ability to create closures and out of state and whatever. And there's a bunch of stuff that is really right.
Well, they also had the advantage of having Guy Steele write the
absolutely.
first spec.
Yep. But and so for all of its issues, it's interesting. You know, I sometimes joke. Show me the perfect programming language, and I'll show you a programming language with no users, because the only languages that are perfect are the ones where you get to fix all the problems, but you cannot you can't go change it once you have users, right? You gotta live with the past mistakes, and then you gotta find ways of engineering better solutions. And so it ultimately becomes this many-headed monster, like HTML or JavaScript or whatever, but that's what all of these technologies that we build our worlds on, that's what they look like, because we're humans and we're fallible and we don't get it right the first time. So
as a language creator, all of you are language creators, how do you manage that growth of a language and, you know, dependencies and the ability to change down the road? And maybe starting with Guido on that one.
Well, with great personal difficulty and sacrifice and emotional issue sometimes, because it sort of, yeah, when success hits, suddenly all your problems are very different than what you thought you were going to have. I mean, I remember seeing a team build a photo app and being super excited about launching the first version. And they had done a beautiful job at what they had built. But what they anticipated would happen next was nothing like what actually happened, because what they had anticipated was they were all stressed out about the sort of what would happen if they were successful. So they were worried about server capacity and bandwidth, and instead what happened, I mean, the server capacity was fine given the growth rate, and the growth rate was adequate, but what killed them was feature requests from users, because users thought, oh wow, a photo app, and it can almost do what I actually want a photo app to do. And so there were like feature requests that all fundamentally would change the architecture of the app to sort of implement those feature requests. And I think that happens to languages as well. I built Python for myself, for my own personal use, and the 2 people I was working with. And we were professional programmers. We had no idea that Python would eventually be so successful as an intro to computer science language, an intro to programming, that it would be especially successful with, say, data scientists and machine learning experts who are very smart people who do not have a computer science education, who have very little training in programming, but who are good at sort of seeing a bunch of examples and generalizing, but now they don't know where the language ends and the library or the framework begins. And as a language, you just have to sort of go with that. You can either sort of tell the users they're wrong, and that does not lead to success. Or you can listen to the users and sort of, you don't necessarily do what the users say they want, because users don't know how language design works, and then they ask for sort of, they have a problem, they think of how they would solve that, and then they ask for that, which is never what you need to do. But nevertheless, you have to listen to them and sort of pull the teeth and sort of figure out what is the real problem that is blocking this user, or what does the user need to enable them, and then sort of figure out how you integrate that in your language.
Yeah, a very long time ago when I was the maintainer of Unix IMAX, when pull requests came on 9-track mag tapes, I would get a whole lot of pull requests, but there was only ever one that I actually just did. Right? All the others I took as a detailed bug report.
Interesting.
Right, because then it's like, oh, well, okay, I understand what's wrong, or I understand but you did it in a completely cockamamie way. Right?
Anders, thoughts on that?
No, I totally agree. I mean, I see that every day in TypeScript, where people don't fully understand how the type checker works, but they hack it in at a grammatical level as opposed to a semantic level or whatever. And so really, what users come to you with is typically an instance of a problem. And it's your job as a language designer to teach out the class of problem they're talking about, and then determining whether, okay, is there something we want to do here? Because people don't think about problems in the abstract. They think about them in the concrete. But as a language designer, you're in a sense creating these abstract constructs that allows problem solving at the instance level, right? And so you have to take it to that meta level as a language designer. I'd say also, I mean, designing V1 of a language is profoundly different from every other version that comes thereafter, because V1 is your green field, right? And that's your chance to sort of get the fundamentals down. But from there on out, you're sort of placed on the spectrum of languages. Are you imperative? Are you functional? Are you declarative? Are you whatever? And you can only move so far, right? I mean, you can try to harvest from the other side or whatever, but you can't fundamentally change the nature of the beast. And a lot of the time, your job, in a sense, is to say no. If you don't know a good solution to a problem in a specific area of the language, rather than rushing ahead and putting something in place, because we gotta have X, Y, or Z, you're probably better off just doing nothing, because then later, if you ever do go there, for sure, the solution is not going to look like the rushed one that you put in place, right? And but it's a tough one because you also want to evolve, right? And you want to listen to your users and whatever. So it's an interesting conundrum. Yeah,
it's a challenge, and I think I'm with you that more conservative probably when you're doing the ABI or the API to the language makes good sense, because once you do it, you've got to maintain it or deprecate it and get rid of it.
Yeah, I mean, what I see often in, not so much necessarily language design, but any kind of software design, right, is that we all want to think about like how my solution is going to be successful, hence it must have some sort of extension model that my people can put in, and so I need to define these interfaces that allow other things to plug into this fantastic ecosystem I'm going to create here, right? But the problem is that you don't really have, so people put in place abstractions without having concrete implementations of the abstraction to inform the abstraction, right? And then, of course, by the time the time arrives where people actually try to use your abstraction, you discover that it's wrong, and now you're saddled with an abstraction you can't get rid of because some people did use it, you know, and so now you gotta have the right one on top of the bad one, right? And so sometimes
what's the
you're
solution
just,
to that?
well, in my book, I always tell my team that, hey, let's not put an abstraction in place here until we genuinely can see here are 3 different problems we could solve with this abstraction. Great, that's gonna inform what the abstraction looks like. Otherwise, just do a one-off and leave it at that. And then you can come back and put abstractions in. You're better off saying nothing.
Right, and as a rule of thumb, 3 is a great number. I mean, I've had that around I've been using 3. You know, it's like, you know, in the early days of Java, people would walk into my office and say, add this feature, it would make the world so much better. And I'd say no. I mean, that was like my standard answer until I had like 3 people with baseball bats at my door. And then I'd say, well, okay, let's talk about it, right? Because until you've got more than one use case, you really don't have any way to reason about an abstraction.
Cool. Any other thoughts, Guido?
Well, I was just gonna say, yeah, I like to solve the problem at hand first before I start abstracting out. But I've worked with people who sort of work the other way. Some people sort of naturally see abstractions everywhere. They tend to design very different kinds of languages that aren't always as successful.
Oh yeah.
Go a little deeper on that because you guys are finding it really funny.
You're asking him to
But
name
it's true.
names,
It's
and
like
that gets embarrassing.
It's the same thing again.
I've seen many. I've worked with many persons who shall remain unnamed. That it's like it's their job to solve this problem, but instead, what they really want to do is build a framework that allows them to solve this problem, and then they start introspecting on the framework for solving their problem, right? And of course, all the time goes into this hole, and then by the time you actually then get to solving the problem, now you have the baggage of this framework that no one asked for, you know, in order to solve your problem, right? And no, I just wanted this problem solved. But so it's human nature, I think. Like some people like to think of, well, wouldn't it be neat if this could be a framework that could solve all of the classes of problems in this area, right? But
So instead of building a door, they built the whole building?
exactly, yeah. It's
Well, they build a machine that builds doors.
But they only have one doorway.
Oh, no.
and the doors are shitty, yeah. But what a machine.
This was a great conversation so far. We're going to transition fairly soon to audience Q&A. We've got 2 volunteers, Pankuri and Batelana, who are going to have roving mics. So I'm going to ask a couple more questions about performance and language design. But I want all of you to start really thinking about what questions you want to ask. And we've had a pretty wide-ranging topic so far. So, you know, ask your hard questions, ask your not-so-hard questions, ask the questions you're confused about. And when you do ask the questions, I respectfully ask you to just state your name, and to make sure when you ask a question, you ask it as a question, not a biography of whatever else is in the world. So performance, people like things to go fast. People want a quick response on things. When you've got a language that's been out there for a while, performance is hard because you're changing things. What are some of the places within a language that you would look for first to optimize performance? And I'll start with Guido.
Well, for about 25 to 30 years, I personally never cared about Python's performance, so that feels hardly fair to ask me that question. Profiling is usually the way to go. There's not any particular thing where you say, oh, if you have a language and it needs to run faster, look at function calls. Who knows how the language is designed? Maybe its function calls are the least of its problems, but variables are. So I wouldn't go to a particular corner of the language. I would just run a profiler that not profiles the programs in your language, but that can profile programs written in the implementation language. In Python's case, that's C. And see what you find. And then you have to treat it as a science project. You have to sort of stop just chasing the numbers that the performance profiler spits out, but you have to start thinking about it and sort of develop a theory about why this part of the language is slow and that part is not, or why you're seeing a certain number of calls of a certain type more, and then sort of try to model that, see if you can sort of, if you would have expected that particular part of the language to be poorly performant. Is garbage collection, is it reasonable that the garbage collection is slow? If not, put some more effort in trying to understand what the garbage collection algorithm is actually doing and see if you can sort of improve the performance there by changing algorithms or maybe just tuning parameters. But you really have to start thinking about what is going on in my language implementation.
I'll add a little bit. I mean, I've worked on many languages in many different capacities, in a sense. I mean, like early on, like on these like simple 8 and 16-bit computers, yes, you had to think a whole lot about code generation and you know, that was sort of like the kind of performance that mattered. In this past project that I'm working on, oddly, I don't really think about the performance of the language, because the language is JavaScript, and the V8 guys or the Chakra guys or the Spider Monkey or whoever, the VM implementers, they think about that performance. I think more about the performance of the tools and the type checker and the, you know,
How do you measure that?
Well, I mean, there are many ways of measuring, but one big headache that we've sort of created for ourselves is we have a very powerful type system in TypeScript, and it is Turing complete. And you can actually write programs in our type system, and that means you have the halting problem, and you have out of memory situation, and it's sort of like at a meta level, the whole world replicates itself, and boy, do we need a debugger for the type system. I mean, it's kind of crazy thoughts. You start thinking that, oh, stop yourself from that. but it's so performance comes, it comes in so many guises, and it permeates everything. The one thing, like I think you said it too, is like never try to address performance without first measuring, because the measurements always tell you something that you didn't think was the case. You mean, I could have, for sure, we need to optimize that function because that for sure runs real slow. And then you go, nope, well, it may be slow, but it just never gets used that much. But over here, by the way, there's this other thing that you hadn't paid attention to, and that's what's taken up all the cycles. but you don't know until you run a profiler. So always start with the data because it'll always surprise you.
Sounds good. James, anything you want to add?
So I absolutely second or third, I guess, the notion that profiling is the first line of defense. One of the problems that I always have with profiling is that, what you hope for with profiling is that you'll find that stupid algorithm over there that you can fix. It's like, what do you mean he's using an n cubed algorithm when there's an on algorithm for that? Those are the days you live for, right? When you can find something genuinely stupid. And sometimes the genuinely stupid things are more subtle than that. But the ones that cause me a lot of heartburn, sort of long-term heartburn, are the performance problems that are kind of like peanut butter, that are spread through things. There are things like, how somebody organized this data structure to be accessed by this because they thought it was this kind of thing, when actually the data structure needed to be accessed that way. But the only way to fix that is to completely revamp the data structure. Those are just painful. I sort of have this other rule of three when I'm building systems, is that I always build at least 2 prototypes and plan to throw them away, because that's the only way that I can get. So by the time I get to about the 3rd time around something, I got a good feeling for where the bottlenecks are, where how the structure of things is going to play out. And lots of people, they try to just rush in and start building a solution. And I kind of like to do my first solution faster, but plan to throw it away. And then plan to throw the next one away. And then by about the 3rd, I sort of like it. But for other sorts of performance, I learned to program in machine code. I'm the sort of person who, when I used to be a C programmer, I used the CC-S a lot. If any of you know what that one does, it at least in the older C compilers, it would spit out the assembly code, and I would treat C code like it was assembly, and I realized that was an illness. But it's when you're doing like device drivers in a kernel, and the performance really, really matters, that's kind of where you go. So I tend to look at code fragments as things. It's like what a code generator often is a theorem prover, and every little bit of information, every little toehold you can give that theorem prover is more information that it can use, and the information that is usually the most powerful is types. The type system being clear and precise not only helps the people, and it helps with diagnostics, but it helps with performance. And so if the end performance of a system really matters, if you're doing something like the transaction processor in the middle of a stock exchange, where you've got 10 microseconds to handle a transaction, you kind of want to think of the instructions one at a time. And type systems help a lot there. But that's kind of a 3rd or 4th order thing if you've got a real system that you're working on.
But it's interesting too how profoundly things have changed, because I started out in assembly code too, right? And wrote compilers in assembly code. Now I'm writing compilers in JavaScript. And I've been doing that for 10 years. And
Which one's better?
And if someone told me that 15 years ago, yeah, that's a funny one. No, that's not going to happen. But it is. And you sit at a whole different level. You sit on top of this swampy ground called a JavaScript VM that all of a sudden will decide, oh, there are too many of these code pages, let me get rid of some of those, and then it de-optimizes some functions, and then all of a sudden things start running 5% slower, and you don't know why. And then you remove that line that you added that, by the way, never got executed, and then it runs 5% faster again. And then you're like, what? And so just even getting to have the ability to measure can be incredibly hard with all of these like VMs and abstraction levels that we've built up. And it goes all the way down to the CPUs as well. I mean, it used to be that I could get out my 8086, programming manual and count the clock cycles and figure out exactly how long this was going to take. Now, everything takes 0 clock cycles because of speculative execution, except when it takes 1,000 clock cycles because you hit the memory wall. And you don't know when that's going to happen because it depends on where the compiler puts it in a code page. So it's crazy, man. I mean, it's much, much harder than it used to be, and it is becoming a less and less exact science. It's really maddening.
Yeah, the only thing you can do is just have faith that the people who did the code generators did their job right.
Well, yeah, I mean.
So code generation, folks, bonus coming up.
Well, and the people doing memory management and the people doing
garbage collection,
Yeah.
So we've had a great conversation so far. I am going to give everyone like a 5-minute bio break as we transition to audience Q&A. So at 2:47, we'll get cracking again. How's that?
Sounds good.
And big round of applause so far for our language creators.